Hello, the first and second demonstrations of the energy bar charts are going to involve this little toy. It's a chicken, and I'm placing it on my front desk. It's got a spring and the toy itself. And we're thinking about the energy transformations that occur. Even though it's elevated above the floor, we can decide where we want our zero position to be. And for example 1, we're going to decide our zero height is on the desk. And for example 2, we're going to decide our zero height is on the floor. Initially, we're going to have this, so it's going to go like that. That is exciting. So the first condition is going to end up being here. The energy when this is compressed and the spring is on the table. The second position is going to be just after it pops off the table, is moving upward. And the final energy condition we're looking at is at the very tippy top of its path, so way up there. So that's the first one. All right, the second example, or actually the third example we're going to have with the energy bar charts is this little alien. It's got a wind-up toy on the back. So I'm going to wind it up. I'm going to put it on the tabletop. And like the first example, we're going to have the tabletop be zero height. If you remember the second example, we changed that to the floor. And in the second example, well, okay, so we'll talk about that. But this is the third example. So the initial condition is when it's wound up, but not yet moving. The middle condition is somewhere where it's moving here across the table. Not sure if you can see that. And then the final example is going to be at the end when it has stopped moving across the table, like right there. I did several bar chart examples with energy on April 19th and April 20th. And so I think that if you look at the videos, which should be at the front of this video, I think it'll help you out. So there's 3 examples. The first 2 are very similar to each other. So with the first one, we had a little toy. It was actually a chicken toy, not a Martian toy. And it was sitting on a tabletop. And the initial condition is where the spring that was attached to the toy was compressed and the toy wasn't moving yet. The second condition, or the middle condition, is when the spring popped up and the toy was moving just after it left the table. And the final condition was the toy was at the very top of its path. So initial condition here, middle condition here, final condition here. We defined zero height to be at the tabletop in this example. And the system, which is the only things we think about when we're thinking about our energy, has got to include the Earth, because if we ever have gravitational potential energy, we have to include the Earth. The toy itself, the spring that's part of the toy, and then the tabletop. In this case, I'm going to say there's no friction, as well as in situation 2 with the Martian toy, popper toy, or the chicken toy. No friction. So in this case, since the initial condition, the spring's not moving and the toy's not moving, there's no kinetic energy. So I've drawn no bars for that. The middle gravitational potential energy is 0 because I defined this as being at 0 height. Since the spring is compressed, I'm going to say it does have energy. The specific number of bars isn't that important, but I give it 4 bars worth. As we go to this middle situation, the spring has just left the table and the toy's just left the table. So the spring is not compressed anymore. So it has 0 elastic potential energy. It's just above the surface, so I gave it a little bit. I gave it half a bar of gravitational potential energy. And it's moving, so I gave it 3.5 bars of kinetic energy. If we don't have any energy flow into or out of the system, in other words, if I didn't apply a force or if something didn't get pushed out of the system, then we don't have energy flowing in or out. So if I have 4 bars here that I start with, I need to have 4 total bars here. And then finally, I need to have 4 total bars there. Okay? So in this particular case then, I've got gravitational potential energy at the end because this is at the tippy top. And therefore, we are going to have, again, gravitational potential energy, no kinetic energy because it's not moving up anymore since it's at the top, but it's not yet moving down because it's at the top. The spring isn't compressed, so we've got no elastic potential energy. And I said there's no friction, so there's no internal energy. In example 2, the Martian popper toy is still on the table, but this time I have the Earth, the toy, the tabletop as part of the system, but I do not have the spring as part of the system. So in this particular case then, I can't include any energy that's stored in the spring in my bar charts. I also moved the zero height down here to the floor, so now this is elevated. Now, when I did this, I made some mistakes here. So I forgot a couple things. I'm going to correct those now. First thing I'm going to do is I'm going to have to make some boxes here, because if the that's a lot. If the floor is the location with zero gravitational potential energy, this is starting above the floor, so it's going to start with some. And I'm going to say it starts with 2 bars of gravitational potential energy. Now, it doesn't have any kinetic energy because it's not moving over here, and it doesn't have any elastic potential energy because the spring is not in the system. Now, over here, when the spring and toy have just popped off the table, it's moving, so I'm going to say again it has 3.5 bars of kinetic energy. Because it's a little higher than it was before, now I'm going to say it has 2.5 bars of gravitational potential energy. So overall, I've got a total of 6 bars. Pardon me, 6 bars. 3.5 plus 2.5. So in this particular case then, what that means is I have to have had energy come from somewhere, and that somewhere is actually going to be from the spring. So if you notice, I have an arrow coming in, and I show 4 bars or 4 boxes of energy coming in from the spring. So whereas here, all 4 of these, or all 3 of these, beginning and middle and end conditions, had 4 total bars. This starts with 2 bars of energy, but I add 4, so now I should have 6. And then, again, I sort of screwed up here. So at this point, that's not what I wanted to do, but I will fix it. I'm going to move this over here, and at the end, at the tippy top of its path, it's going to have all gravitational potential energy, but I've actually got to make that like 6 bars worth, because I have 6 total bars of energy. So I kind of screwed up on that. But hopefully this fixes it a little bit, and hopefully you can understand that. So 2 bars of gravitational potential energy because the zero height's at the floor instead of the tabletop. The spring is not in the system, so we have to get the energy from the spring, so that's coming in here in the energy flow diagram. Here we have the same amount of energy, basically, of kinetic energy as we had up here. We have more gravitational potential energy than we had up here because, again, the zero height is now the floor. And then as we go here to this final condition, we have all gravitational potential energy. We have 6 bars because we had 6 total bars of energy here, and no energy entering or leaving the system between these 2 situations. The other video, which hopefully showed, was the ambling alien, which is kind of fun. And the ambling alien ended up moving across the tabletop. I wound the spring, and again, hopefully you see the video with that. And I wound it up, and it started moving across the table, and it ended up stopping at the table. In this case, I'm going to call zero height the tabletop, so I'm not going to make that kind of goofy like I did in the second example. So in this case, initially, the alien's wound up but not moving. In the middle case, it's moving across the table, and then in the last case, it stopped, and that is stopped after moving. Okay, so here, I wound up a spring, so I'm going to say it has 4 bars of elastic potential energy. It's on the tabletop. I've defined that as zero height, so that's going to be 0 gravitational potential energy in all 3 of these bar charts. In the initial condition, the alien's not moving yet, so it has no kinetic energy, so we've got 4 total bars of energy. A little later on, it's moving, so it's got to have some kinetic energy. I gave it 1 bar. There's still some energy in the spring because it's not done moving yet, so I left that at 2 bars of energy. And then I think it has to have some of this. I wasn't sure about that until I went over here. So the final situation, it's not moving anymore, so it has no kinetic energy, no gravitational potential energy for reasons I mentioned earlier, no elastic potential energy because there's no spring involved anymore. The spring is completely unwound. So if energy is conserved and I don't have energy entering or leaving the system, I need to have 4 total bars of energy at the beginning, middle, and end. Well, at the end, the only place it could be is heat. And if I include the Earth, the toy, and the surface, the heat is probably in one of those places, probably mostly inside the toy. So when I went back here, I realized that if I had all this heat energy here, I probably had some of it building up here. So I did give it a bar of internal energy here as well. So I have 1 plus 2 plus 1 is 4 bars of energy. Hopefully this helps you understand if you weren't here in class, or as a refresher if you were here in class.